can't differentiate immediately. Simplify first, right? So how do you simplify this?
2t plus 1 over t.
2t plus 1 what?
Over t.
Then?
Plus t minus 2 over t.
Plus, where's the plus in between here?
It's no plus. Minus.
So, 2t plus 1 over t times t minus 2.
Huh?
Why do you want to do this then?
Take t minus 1. Yeah, take t minus 1.
Huh? What t minus 1?
You take the t out.
What?
You move the t out, so it becomes t minus 1.
Move the t
t to the power minus 1.
I think Brian writes it over.
Okay. Then, Brian, then continue.
Then you expand.
How to expand, may I know? So what will you get when you expand? Can you tell me?
Oh my god. Right, it's very.
2t square minus minus 4t plus t minus 2.
Then,
bracket t minus 2.
okay. Then
expand.
Then expand how?
2t minus 4 plus 1 minus 2t minus 1.
Okay. Actually, okay, there is nothing wrong with your method. Okay, just that it was a bit strange to actually bring up the t to t become -1 first. Alright. You could actually expand the numerator first, then after it simplify. But up to here, it is fine. Okay, so when you simplify the expression for y, right, okay, you will get this. Then after that, when you want to differentiate, you will be differentiating with respect to t. Okay, so in this case, you will get 2 minus 2 times -1t minus 1 minus 1. Okay, so then this will be answer. You get that?
No.
Why?
Yeah.
Then who asked for 6m? You right, you asked for 6m, right? So what's wrong?
No.
Okay, what?
You asked if you get the answer. You asked if you for what? I said no. You said yes.
Okay. Yes, I'm very confused. Okay, 9C. Okay, I think we are given 2 equations, right? One curve and then also one straight line. Alright? Okay, so we want to calculate the gradient of the curve at the point where it crosses the given line. Okay, so with this as our first equation, we can simplify it to achieve this. Then after that, we will first differentiate this one and we would get this, right? Okay, then after that, the question says that we want to find the gradient of the curve where it crosses the given line, okay, whereby it crosses this, so we need to know what is the point. Okay, so this is our first equation for the curve, and then after that, our line refers to this one. So we need to find the given point, so we do our substitution. And then we will get 2 points, x equals to 2 or x equals to -1. So at the respective points, right, we will find out what's the gradient. Using our derivative over here. Okay, so our gradients will be -1/2 and -2. Right? questions? If not, will you please submit your homework to the front? Oh, nice.
That's the hard part.
Yes, yes. Sorry, I cannot hear Sijie. Yeah. What do you mean by bracket? We don't put dy over dx brackets, right? It's d over dx brackets. Yeah. dy over dx means that you are differentiating y with respect to x when you have a y being defined. Otherwise, you will use d over dx to represent that I am going to differentiate the things in the bracket with respect to x. Understand? Okay, let's continue with our chapter 14. Okay, could we all look at quotient rule today? Alright, chapter 14.4. Okay, so actually this will kind of round up all the rules that we will need, okay, to help us go on the entire 14, 15, 16, and 17, I think. Okay, so we have already learned what if two differentials or rather two expressions are added or subtracting one another. Okay, what would we do with that? And then also we have also covered product rule. Right, so today we will cover quotient rule. Okay, so we are looking at how do we differentiate things like this. Okay, because in this case, this expression cannot be further simplified. Okay, although quotient rule is a unique case for product rule. Alright, so you could actually, if you want to, change it into a product of two expressions and then you apply product rule. Okay, but sometimes maybe you find that doing quotient rule will be easier when it comes to further simplifying the whole expression. Okay, so that's why we will want to ask ourselves, okay, how do we actually simplify this by using our quotient rule? Okay, so what the quotient rule states is that, okay, if I have an algebraic expression whereby u and v are in terms of x, okay, so there are some function in terms of x. Okay, what do we do is that we take the bottom, okay, keep the bottom, we differentiate the top, then minus away, keep the top, differentiate the bottom, then further divide by v squared. Okay, so this is what the quotient rule actually states. Okay, so in order to apply the quotient rule onto this question that we just threw ourselves earlier on, okay, so in order to differentiate dy over dx, Okay, we will keep the bottom x plus 1 square, differentiate the top x, right, that will be equals to 1, minus away, keep the top, differentiate the bottom. Okay, differentiating x plus 1 square will give you 2 times x plus 1. Right, then after that, for the denominator, it will be x plus 1 square, and then after that, further square again. So in other words, that will be to the power of 4 lah. Okay, in this case, like always, alright, we always simplify the algebraic fraction, okay, as much as we can, okay, because there is a common factor of x plus 1 in the numerator and in the denominator, okay, so we will factorize and then we'll be able to cancel out. And then the simplest form will be this one. Any questions? If no questions, I would like you to try 14 on your own. Differentiate this one using the quotient rule with respect to x.